So if we think broadly about especially peripartal cows, that you can think broadly as there's an influx of hormones, and a lot of this is driving that lipolysis. Um, but really not understanding the main instigator of lipolysis itself kind of closes a lot of doors to be able to develop therapeutic treatments or to be able to attenuate metabolic diseases. We know that excessive lipolysis can lead to metabolic disorders and diseases. So uh, I really think that we should care about it because it's a whole other area that we can develop therapeutic approaches and help attenuate metabolic diseases and then improve dairy cow health in the future.
Welcome to the Dairy Health Blackbelt Podcast, brought to you by Wisethetics. This podcast is dedicated to bringing to you the latest insights and discussions in the dairy science. I'm Dr. Luciano Cacheta, your host for today, and today I have the pleasure to have as a guest Bridger Sparks, who is a PhD candidate in neurobiology of the adipose tissue at the Texas Tech University.
Thank you for having me. I'm excited to be here.
Yeah, no, it's good to have you here. So I have a lot of work that I've done on metabolic diseases and management and all of those cows in the transition period. And we know about this cows mobilizing fat, and we all talk about this. But you go a step further because you're studying like the nervous system within the adipose tissue. So why did you choose that area of research?
Yeah, I have always been interested in the nervous system, and I've always been interested in metabolic diseases. In my earlier research training, especially during undergrad, I dealt with like type 1 diabetes models and then separately peripheral nerve injuries. And so when I was approached by my current advisor, Dr. Clarissa Strider-Barboza, we came together and said, why don't we just merge the two? We know as dairy scientists and as adipose tissue biologists that the nervous system is incredibly important in regulating that lipid mobilization. So a lot of information is known about the side effects of excessive lipid mobilization. Not too much is known about the characteristics of that upper stream system and how it actually regulates the lipolysis itself.
Wisethetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
So I think that's like bring us to like why we should care, right? About this innervations within the adipose tissue. We have seen before like the adipose tissue being like almost like producing a lot of hormones and managing like in the endocrine side of things. And now we have the in the nervous part of things. So why should we care about it?
Yeah, I think so. If we think broadly about especially peripartal cows, that you can think broadly as there's an influx of hormones, and a lot of this is driving that lipolysis. But really not understanding the main instigator of lipolysis itself kind of closes a lot of doors to be able to develop therapeutic treatments or to be able to attenuate metabolic diseases. We know that excessive lipolysis can lead to metabolic disorders and diseases. So I really think that we should care about it because it's a whole other area that we can develop therapeutic approaches and help attenuate metabolic diseases and then improve dairy cow health in the future.
No, that's interesting. Like I said, being upstream then give you a chance to deal with or control whichever term we want to use before all that metabolic, the mobilization, the metabolic issues are there, right? One thing that when I look into my data sets and the things that we do, and many times like we talk about, like when we talk about metabolic issues, like I work a lot of hyperketonemia, and for some like to be more efficient, sometimes when I'm doing those very intensive trials, I don't even enroll first lactation cows, right? Because when I measure high BHP, which is what we measure easily and cheaply for the mobilization, like it's not even worth the material because there's very few of them. So do you see on this upstream part of it like a difference between those younger cows, like the primiparous cows versus like the older cows?
Yeah, parity was a thing that we kind of got hit with from left field. Like we too, when we do studies, try and control for that parity effect. In my current work that I've done, we actually don't have any primiparous cows in it. They're just cows on their second lactation or higher. But parity definitely appears to be driving a lot of influence in the actual innervation of adipose tissue. So we just recently submitted something that we took second lactation cows versus third lactation cows versus fourth or higher lactation cows. And what we saw was as you increase in parity, you also increase in innervation. And so we don't know completely, but it appears that this innervation may be able to control the lipolysis better or mobilize more. But there's also some enzymes that are pretty important in the production of things like adrenaline or noradrenaline, which are incredibly important for that lipolysis or liberation of fat. So when we look at the enzymes regulating that, we see a difference in some rate limiting or upstream enzymes, but the actual enzyme that's responsible for the final cue of taking dopamine to norepinephrine, it's known as dopamine beta hydroxylase, it actually has an inverse relationship. So we have, as cows get older, they increase their innervation. They also increase their upstream mechanisms of production of catecholamines. But then there's the flip. So as a cow gets older, they have less dopamine beta hydroxylase. So our theory is that as cows get older, they're actually producing less noradrenaline or norepinephrine, but they're compensating by more tightly regulating this by using the reuptake transporters that are actually on the end of those nerves. So very complicated. It appears that as you get older, you increase your innervation, which is interesting because that's kind of flipped from what we see in other models, like mice models.
That's very interesting. And the one thing, so in those sound like very intensive studies, and you have to do biopsies to collect those specimens. So I don't like, are you using like most of the cows that had like high BHP or something like that? Do you screen them and then you pick the ones that you want? Or do you collect a gobba of cows, like a bunch of cows, and then decide and then use that for your analysis? And the reason I'm asking that is like, do you see differences in this innervation and how those play a role in cows that are with high BHP versus cows that don't have a high BHP?
Yeah. So the current study that we have just done was originally targeted at being a periparturient study. So it's pre and postpartum sampling points. Cows were just enrolled as a group. There was minimal criteria. We just wanted a general population to be able to describe if there is a shift in that innervation because of acute metabolic remodeling or what's going on. So this current study, we only had about, I think it was 44% of the cows actually developed some sort of metabolic disease within the first 7 days, and only like 3 of those were ketosis. So we're not currently able to see if there's any true relationship between the metabolic diseases and the actual innervation or with the parity. I will tell you that we just did some other analysis with a different group where we only looked at postpartum cows that was by selecting hyperketonemic. So cows that were more like subclinical ketotic animals versus just control animals that had their BHB was 0.8 or lower. And we did mass spec on their tissues to look at the actual concentrations of all of the monoamines that are in the tissue at that present time. And we did observe a relationship between norepinephrine with increased NEFA and increased BHB, as well as when we separated cows by their control groups of ketotic versus control. We did see relationships within those. So going forward, we have another periparturient study that I will plan to do more innervation stuff with. So I'm hoping that that will give us a little bit more description of, is this a one-time thing that we're just seeing this with subclinical cows, or is this something that's actually carried on throughout the entire periparturient and also with parity and metabolic diseases?
No, that's super exciting. And like, just wrap up, we're coming up at time here, but in the beginning you said like you're using this and studying this to try to better understand and potentially have better ways, strategies to control or to manage those cows. So how do you see this, the knowledge and the topic you're studying playing a role into like the management of periparturient cows in the future?
Yeah, that's it. I am a very basic scientist. And so when I think about that, I think of the possibility of being selective about who we're breeding, who we're not breeding. Obviously, a longitudinal study is needed to get a better grasp on that. But I think if you're able to isolate cows that are able to mobilize and it's reflective of that highly innervated tissue compared to cows that are not, or vice versa, if cows need less innervation to maintain a healthier transition, I think there's the ability to long-term be able to selectively breed from that by eventually establishing what does that look like, whether that's we can test for biomarkers to get a reflective what's happening in the tissue, or if we have to go along cows, take biopsies, and then establish that.
No, that's cool, and like it sounds very interesting, and sounds like you still have a lot of work ahead of you. I know you still have some work during your PhD, and like I assume you're gonna continue on that front, and gonna continue to bring us some knowledge on this in the future. Good luck to you on that, and I appreciate that you spent some time with us. Thank you.
Thank you so much for inviting me.
This concludes another episode of the Dairy Health Blackbelt Podcast presented to you by Wisenetics. Thank you for joining us today. Don't forget to subscribe to our podcast to stay updated about future episodes. And if you enjoyed today's episode, please leave us a message, review, and your feedback is super important for us to guide us on what the next podcast will be for you. Until next time, I'm Luciano Cacheta, and this is the Dairy Health Blackbelt Podcast. Thank you. Bye.